All right, welcome to lesson 4. Mr. Garrick here, obviously. So multiplication properties of exponents number 2. Looking at the learning targets, use the multiplication properties of exponents to simplify expressions. But number 2 is the one that I want you to make sure you see. Differentiate between the various properties and use them accurately to simplify expressions. So what am I talking about between differentiation? Well, let's start with what we learned last lesson. Just a reminder here. So last lesson, we had a to the m times a to the n, and we added the exponents. How many bases did we see in the beginning? Well, there were 2 bases, and there were 2 exponents, right? And what that meant, this is a little trick that we can use to help differentiate. So there were 2 bases. Each of those bases had an exponent, and that was a clue to add the exponents. The new stuff that we're doing, if I scroll down, so x to the 4th to the 3rd power. So what that means is x to the 4th times x to the 4th times x to the 4th. Using the old property, we know that this simplifies to, well, we have 3 x's all being multiplied, 4 plus 4 plus 4, x to the 12th. So what's the shortcut? Starting here, how do I go to x to the 12th without having to write it all out like I did in that step? Well, 4 times 3 is what you would do. So x to the 4th to the 3rd power equals x to the 4 times 3, which equals x to the 12th. Okay. So what new property help you understand it and help you to differentiate between what we did before and what we're doing now? How many bases do we see when we start this thing? So right there, how many bases do we see? 1. How many exponents does that base have? 2. Again, another place we're seeing it right here. A to the m to the n power is a to the m times n. Okay. Jumping straight into some practice. 3 to the 5th to the 4th. So what I do is just multiply. Multiply 5 times 4. You get 3 to the 20th. It's a very big number. I'm not going to write that out. You could get it though. Number 2, e to the negative 4th to the negative 2nd. We are still dealing with negative exponents, and you still might have to move things. But the nice thing sometimes that happens is, watch what happens here. Negative 4 times negative 2 is positive 8. No need to move anything. There it is. Number 3, a lot of people think negative 24 here. Careful. This is an old one. I threw it back in to see if you were doing what you were doing. M to the 6th times m to the negative 4th. That's 2 different base, or 2 of the same base, but 2 of them. So I add those exponents. M to the 6th, m to the negative 4th. 6 plus negative 4 is m to the 2nd. Number 4, c to the 5th to the negative 3rd is c to the negative 15th. Not happy on top, goes to the bottom, c to the 15th on the bottom. The 1 on top. All right, now we've got a couple things going on with number 5. Order of operations is what we want to do first. So this is exponents. And once we're done with that, we would do the multiplication, right? So erase that real quick. So what I need to do is the k to the 6th to the 2nd first, and that gives me k to the 12th. And then times k to the 5th, I'm going to be multiplying those 2 terms. The shortcut is 12 plus 5, k to the 17th. Okay, number 6. Again, same idea, but the exponent's over here this time. So x to the 3rd is going to get multiplied in at the end, and that's x to the negative 14th. Negative 7 times 2 is negative 14. And then 3 plus negative 14, again, we're multiplying, but the shortcut is to add those. 3 plus negative 14 is negative 11. X is not happy on the top. It goes to the bottom and becomes 1 over x to the 11th. A lot of you are probably thinking, oh, that's not too bad. Be correct. It's not too bad until I make it harder, right? Backside. What happens when there is more in the parentheses? Example, 5x to the 3rd squared. Well, if we rewrite this expression, think about what squared means. That means 5x to the third times 5x to the third. That simplifies to, well, 5 times 5 gives me 25 x to the sixth, right? There is a little trick for remembering this. Make sure that each base has an exponent before you begin. What do I mean by that? Back up to this problem. 5 is a separate base than x. 5 has an exponent. It's not written, but if I wanted to put an exponent there, I'd put a 1, right? So that's like 5 to the first times x to the third. Okay. What you would do then is you would multiply each exponent by 2. So watch what happens. 5, 1 times 2 is 2. And then x to the third, 3 times 2 is 6. 5 squared is 25, which is what we got here, x to the sixth. That's how you're going to do a lot better if you do it that way. Okay, some practice. 2z to the fourth. I'm going to make sure each base has an exponent. So there's a 1 on each of those. So I'm going to multiply each one by 4. So 2 to the fourth, z to the fourth. And now I just simplify what I can. 2 to the fourth is 16. Z to the fourth, I can't do anything with. 3g to the negative fifth squared. Make sure each base has an exponent. And now all you're doing is you're multiplying each exponent by 2. So 1 times 2. And g to the negative fifth, negative 5 times 2 is negative 10. So that's 9g to the negative 10th. All right. G is not happy on the bottom, sorry, on the top, so it goes to the bottom. 9, just find where it's at. So it's 9 over g to the 10th. Okay. Number 3, 2 has an exponent of 1. A lot of people see that 0 exponent, they think, oh, the answer is 1. It's not. Each exponent gets multiplied by 3. So 2 to the 1 times 3 is 3. 0 times 3 is still 0. But 2 to the third is 8. T to the 0 is just 1, so that equals just 1. So it's just 8 times 1, or 8. Before I move on to number 4, I want to show you one thing. That first step where I put 1s on each base, notice that when I multiply the exponents, the bases don't change. 2 and z still there. 3 and g still there. Number 3, the bases of 2 and t still there. The only thing that's changing in step 1, if you're doing it the way I'm asking you to do it, the only thing that changes is the exponent. I have some people that try to do it their own way, and they start making a lot of mistakes. Okay. Moving on. Number 4. Exponent of 1 for the 2 there. So 1 times 0 is 0. 3 times 0 is 0. Now that is 1 times 1, which is just 1. Okay. Number 5. Starting to get a little more complicated here. Make sure every base has an exponent. C already has one. 3 does not. C already has one. So I'm going to multiply that 3 there. That first exponent of 3 only applies to the c squared. So that's c to the 6th. And then I'm going to look at this one. Times 1 times 3 is 3. 5 times 3 is 15. Now I'm just going to simplify a little bit further. 3 to the third power is 27. They are both c's, so c to the 6th and c to the 15th. I can add those exponents. That would be c to the 21st. Number 6, exponent. All bases have an exponent. 2 needs 1, 3 needs 1, and a needs 1. Again, only multiplying exponents at this point. So 2, 1 times 5 is 5. A to the 15th. Now, I'm looking at now the exponent of 3. So 3 to the 3rd, a to the 3rd, b to the 6th. Now I'm going to simplify my numbers real quick. 2 to the 5th is 32. A to the 15th times 3 to the 3rd is 27. a to the third, b to the sixth. Common problem that I see people do is they take that 32 and 27 and they add them. There's no plus sign in here. I'm not adding 32 and 27. I'm going to multiply 32 and 27. And yes, it's a big number. Doesn't matter. 864. I am going to put my a's together. A to the 15th and a to the third makes a to the 18th. And left over b to the 6th. And that one's done. Okay, number 7. This one's tricky because of that negative. Okay. Look at it as -5 to the first power, m to the first power, n to the first power, 4 to the first power. So -5 to the third power. I'm putting that in parentheses because that whole thing was -5. The base is -5 to the third power. M to the third power, n to the third power, times 4 to the second power, m to the -6th. All right, -5 to the third power is -5 times -5, which is 25, times -5, which is -125. And then m to the third, n to the third. I'm not changing anything yet. 4 squared is 16, m to the -6th. So -125 times 16 is -2000. So -2000. M's I can put together to make m to the -3rd, right? 3 and -6 makes -3. N to the third. Now I'm going to make all your exponents happy. -2000 is not an exponent, so -2000 stays on top. M goes to the bottom, becomes m to the third. N stays on top, becomes n to the third. And that one's done. A lot of work there, so I'm going to circle it. Go back up here to this one too. Okay, number 8, last one here. All that junk's on the bottom. Makes it look a lot harder. It's not. You do the same thing. So everything in the parentheses has an exponent. So 2 to the first, x to the 6th, y to the -4th. And now I'm going to multiply all those exponents by -3. So 1 times -3, 6 times -3, and -4 times -3 is +12. Now it's just a matter of moving things around. Okay, so 2 is not happy on the bottom, it goes to the top, 2 to the third. X goes to the top as well, x to the 18th. Y stays on the bottom. 2 to the third is 8, so I'm 8x to the 18th over y to the 12th. So you can see these can get kind of complicated, but if you go slow and go step by step, you shouldn't have too much trouble. Finishing this up, scientific notation. It's very similar to the last lesson, so I'm not going to spend a ton of time. 3.1 times 10 to the 8th squared. If you just understand what squared means, that means 3.1 times 10 to the 8th times 3.1 times 10 to the 8th. And now you're doing exactly what you did in the last lesson. So 3.1 times 3.1, 9.61. So what I did is just multiply those two, and then I'm multiplying these two. 10 to the 8th times 10 to the 8th is 10 to the 16th. And because 9.61 is less than 10, I'm done. That's the answer. We'll do number 2, 5. I recommend writing it out. I still do to this day. So it's a good habit to get into. 5 times 5 is 25 times 10 to the -12th. Okay, and then 2.5. I made that smaller. So I got to make the exponent bigger by 1. So -12 plus 1 is -11. And that's it. Okay, and that is your multiplication properties of exponents. We're going to move on to division with the next lesson.